The WingtraRAY is a cutting-edge VTOL, vertical takeoff and landing, drone designed by Swiss innovators WingtraRAY, purpose-built for fast, high-accuracy aerial surveying. Blending the vertical lift of a multi-rotor with the long-range efficiency of a fixed-wing aircraft, the WingtraRAY launches vertically before transitioning seamlessly to forward flight. It supports cruise speeds from 36 to 49 miles per hour and accepts modular payloads including a 61MP mapping camera, multispectral imaging systems, LiDAR scanners, and inspection-grade sensors. Capable of mapping up to 550 hectares in a single flight or 100 hectares in just 10 minutes, the WingtraRAY delivers survey-grade precision with 3 cm accuracy and imagery as fine as 2.5 mm per pixel. Engineered for urban compliance, it offers an optional certified parachute for safe flight over populated zones, in line with FAA and EU regulations. With a maximum flight time of 59 minutes, dual-link telemetry, radio and LTE, onboard obstacle avoidance, and full integration with the WingtraRAY ground and cloud platforms, this drone redefines scalable, professional-grade geospatial data collection. The DJI Agras T100 is a high-capacity agricultural drone engineered for large-scale and complex farming tasks. Its robust and modular design enables it to handle spraying, spreading, and lifting with ease. Built with a coaxial twin-rotor system and massive 62-inch carbon fiber propellers, the T100 reaches flight speeds of up to 20 meters per second, 44 miles per hour, covering large fields efficiently. The drone comes equipped with a 75-liter spray tank capable of delivering 40 liters per minute, making it ideal for penetrating thick crop canopies. For spreading applications, the T100 includes a 150-liter spreader that can distribute up to 400 kilograms of seed or fertilizer per minute with customizable spread widths. It also offers a heavy lift mode, carrying up to 85 kilograms, perfect for transporting supplies across rough terrain. Advanced features like a LiDAR system, millimeter wave radar, and a 5-eye fisheye camera provide full 360 degrees obstacle sensing. With AI-powered flight planning and RTK precision positioning, it ensures accurate, safe operations. The 41Ah smart battery recharges in just 8 to 9 minutes, making the T100 a highly efficient and versatile tool for precision agriculture. The Blue Ring Pathfinder is a technology demonstration mission by Blue Origin, designed to validate critical components of its upcoming Blue Ring orbital platform. Instead of full deployment, the Pathfinder remained integrated with the second stage of the inaugural New Glenn rocket, allowing in-orbit testing of core systems such as power, communications, and onboard computing. This mission also evaluates the platform's maneuvering capabilities and modular design, which supports 13 payload ports adaptable to a range of orbital tasks. Engineered for versatility, the Blue Ring system is intended to support missions from geostationary orbit to lunar and deep space operations. Its adaptability makes it suitable for defense, commercial, and scientific payloads. The New Glenn rocket, which launched the Pathfinder, features a powerful 7-engine B-4 setup and a 7-meter fairing to accommodate oversized payloads. With a reusable first stage designed for up to 25 missions, this launch vehicle marks a new era of scalable, flexible space infrastructure. Blue Ring Pathfinder is a pivotal step in building the modular architecture needed for the next generation of orbital logistics and exploration. Google's Willow Quantum chip represents a major leap toward building practical, large-scale quantum computers. Featuring 105 superconducting transmon qubits arranged in a lattice, Willow introduces a powerful error correction system by organizing physical qubits into logical units. This design lowers overall error rates and pushes the system into a below-threshold zone critical for achieving consistent and reliable quantum operations as the hardware scales. One of Willow's most striking achievements is its ability to solve a complex random circuit sampling problem in under 5 minutes, something that would take classical supercomputers trillions of years. It also delivers 100 microseconds of qubit coherence time, a 5-fold improvement over previous models, boosting system reliability. Unlike earlier quantum systems, Willow gains performance as more qubits are added, breaking the traditional trade-off between scale and noise. With future applications ranging from AI and cryptography to clean energy and materials, Willow marks a turning point on the path to fully fault-tolerant quantum computing. The XB-70 Valkyrie was a revolutionary aircraft born from Cold War ambitions, originally conceived as a Mach 3+ strategic bomber capable of cruising at 70,000 feet. Engineered by North American Rockwell, it was designed to evade enemy defenses not by stealth, but through raw speed and altitude, outrunning threats before they could react. Despite its extraordinary capabilities, only 2 prototypes were ever built, and the bomber program was ultimately cancelled due to shifting military priorities and emerging missile technologies. Yet the Valkyrie's story didn't end there. Its unmatched performance sparked bold visions of it serving as a hypersonic launch platform, a futuristic mothership that could release rockets or spaceplanes from high in the atmosphere. While that vision never came to life, the XB-70 inspired generations of aerospace engineers and laid early groundwork for today's airborne space launch concepts. It remains a symbol of innovation, pushing the boundaries of what flight could be. Set to debut in 2027, Europe's Space Rider represents a leap forward in reusable orbital vehicles. Designed through a collaboration between the European and Italian space agencies, this autonomous spaceplane will launch atop the Vega C++ rocket, delivering up to 600 kilograms of research payloads into low Earth orbit. Functioning as a robotic lab, it will support cutting-edge experiments in microgravity, advanced materials, and biomedicine inside its 1,200-liter cargo bay. With the ability to remain in orbit for up to 2 months, Space Rider is powered by a detachable service module that supports its operations. At mission's end, it will discard the module and glide back to Earth using a guided parafoil system, touching down with runway precision. Building on Europe's earlier re-entry tech achievements, Space Rider is set to offer a cost-effective and repeatable way to access space, opening new doors for science, industry, and technology testing in orbit. The ReNova, short for Reusable Nova, was an ambitious 1960s rocket concept that aimed to achieve orbit and return in a single, integrated stage. Unlike traditional multi-stage rockets, ReNova proposed a fully reusable system with no discarded components. Its standout innovation was an air-breathing ascent system. By drawing in atmospheric air and mixing it with rocket exhaust during early flight, it boosted efficiency and reduced onboard fuel use. Once outside the atmosphere, ReNova would switch to conventional rocket mode, powered by hydrogen and oxygen through a toroidal aerospike-style engine. Designed to haul up to 450,000 kilograms into orbit and return using parachutes for soft recovery, the vehicle was ahead of its time. Though it never left the drawing board, ReNova's visionary design continues to influence modern efforts toward fully reusable and fuel-efficient spaceflight. Zephalto is redefining high-altitude travel with Celeste, a luxury capsule designed to carry guests to the edge of space without the need for rockets. Instead, a massive helium balloon gently lifts the pressurized capsule to 25 kilometers above Earth, where travelers can witness the curve of the planet and the vast darkness of near space in serene comfort. The full 6-hour voyage features a 90-minute ascent, 3 hours of peaceful cruising in the stratosphere, and a gradual descent, all engineered for ease and elegance. Developed with support from the French space agency NIS and envisioned by architect Joseph Durand, Celeste blends aerospace innovation with upscale hospitality. Guests will enjoy panoramic views through floor-to-ceiling windows, savor gourmet meals crafted by Michelin-starred chefs, sip fine wines, and stay connected via onboard Wi-Fi. With commercial flights slated for 2025 and ticket prices ranging from $132,000 to $170,000, Zephalto promises an unforgettable journey to the edge of space, wrapped in timeless French sophistication. Dassault Aviation's Vortex is a bold leap toward a reusable European spaceplane, unveiled at the 2025 Paris Air Show as part of a vision to transform access to space. Designed for vertical launch and horizontal jet-like landings, Vortex combines rocket power with aircraft-style recovery for rapid turnaround and operational flexibility. Backed by €30 million in funding from the French Ministry of Armed Forces and aligned with ESA's Explore 2040 roadmap, the project will unfold through progressive development from scaled prototypes to full-scale missions. Engineered with a spacious payload bay and advanced re-entry controls, Vortex is built for a range of missions including satellite servicing, cargo resupply, defense applications, and future crewed flights. Its reusability and precision landing capabilities aim to cut costs and reduce dependence on non-European launch systems. Representing a strategic step toward autonomous and sustainable space operations, Vortex is set to play a pivotal role in shaping Europe's next-generation orbital presence. The Rockwell C-1057, often dubbed the Flying Breadbox, was a daring 1970s space shuttle proposal that reimagined how orbital cargo could be carried. Developed by North American Rockwell, the concept featured a radically reoriented 90-degree payload bay, creating a short, wide fuselage unlike anything seen in traditional shuttle designs. The goal was to reduce the shuttle's overall length while preserving internal volume, resulting in a boxy, compact profile influenced by lifting body research and novel aerodynamic thinking. Though the C-1057 never progressed beyond paper, it stands as a compelling example of boundary-pushing aerospace design during the formative years of reusable spaceflight. Its unorthodox approach highlights the innovative spirit of the era, sparking interest among historians and space enthusiasts as a symbol of imaginative engineering in the pursuit of practical solutions for space travel. The Precision Exportable Launched Effect, PLE, is a cutting-edge, lightweight unmanned aircraft system developed by General Atomics Aeronautical Systems Incorporated, engineered to complement modern aerial platforms. PLE can be deployed from the MQ-9B Sky Guardian or ground-based launchers to serve as a force-extending asset in high-risk environments. With an 11-foot wingspan and a 16-horsepower engine, this compact, propeller-driven drone is capable of flying over 570 miles and remaining airborne for up to 7 hours. Designed for adaptability, PLE carries modular payloads to perform a variety of roles from ISR and electronic warfare to comms relay and beyond. Its affordability and semi-autonomous capabilities make it ideal for missions too dangerous or costly for traditional assets. Built with scalability and rapid deployment in mind, PLE enhances the reach, responsiveness, and survivability of larger uncrewed systems across evolving combat zones. SpaceX's Starship represents the next giant leap in interplanetary exploration, with its sights firmly set on Mars. Engineered as a fully reusable spacecraft paired with the Super Heavy booster, Starship is built to transport over 100 metric tons of crew or cargo, redefining the scale of space missions. Elon Musk's vision includes an uncrewed mission by 2026, followed by a human landing as early as 2028 or 2029. The mission blueprint includes orbital refueling, precision Mars landings, and producing methane fuel on-site using Martian resources for the return journey. This approach lays the groundwork for establishing Mars Base Alpha, SpaceX's proposed foundation for a sustainable human presence on the Red Planet. With a growing list of successful test flights, Starship is transitioning from prototype to a transformative vehicle at the heart of a multiplanetary future.